if battery technology advanced like semiconductors have, you would have a device the size of a pinhead that could power your car and it cost a penny. And we're never going to have that. If you want to get much, much denser power than we have in a battery now, you could use nuclear. And I don't think we're going to see nuclear in a wearable device anytime in the future that I can predict. So you're limited by the storage capacity of chemical energy. And we're making progress. Every year it gets a little better, but it's not going to get double in next year. So that limitation will remain indefinitely. So you got to work around it. You've got to trade off between how long between charges and how small the battery is, which determines, in many cases, the size of the whole device. The other thing you work on is how far are you going to transmit? If you've got a wireless device, if you transmit to your cell phone in your pocket, it takes a lot less power than if you're transmitting to a cell tower that's several miles away. So the type of transmission will determine the power that's used. You can also operate something in short bursts. So if you've got a small amount of data, you don't have to have the transmitter on all the time. You collect it for a while, and then you turn it on, send a bunch of data, and turn it off. And then you can use devices that are lower power. For example, GPS is it's moderate power. If it's on all the time, it's going to use quite a bit of battery during the whole day. An accelerometer uses a lot less power. In fact, if you combine an accelerometer, accelerometer and a gyroscope and so on, you can keep track of where you are for a while. Eventually it gets errors. So you could turn on the GPS every now and then and make a correction, but in the meantime you could use a lower power device. Yes?
So there are watches powered by the movement of your arm. There are watches powered by light. I think there probably are ways of generating power from the heat coming off your body. Are there other ways besides batteries being looked at?
So the question is about energy harvesting from heat and movement and other areas. Energy harvesting generates power in the milliwatts and microwatts. And most useful devices that are being sold today are in the tens of milliwatts and hundreds of milliwatts. So energy harvesting isn't useful for most of the wearable devices. I wish it were, and there's definitely work going on there. And it depends upon what trade-offs you're willing to make. If you're willing to have a simple device that's not very powerful, doesn't send doesn't send the information very far in distance, you could use energy harvesting.